All right, our final conic section is a hyperbola. Our definition for an ellipse, where the sum of the distance from each foci constant. Our definition for hyperbola is really similar, except take difference of the distances to the two foci. Right? So our equations for our hyperbolas are almost identical to the equations of an ellipse, with the exception of a subtraction sign instead of an addition sign. Right? So before we get into dissecting the equations, we do have a couple of terms. We've already talked about a vertex. Right? Now, a vertex is the same idea that we talked about parabolas. Okay? The vertices are these points here. Right? They're essentially the end points of each piece of the hyperbola. Okay? Just like it was like the end point of a parabola. So we can think of them as endpoints of each piece of the hyperbola. Now, a couple of new terms. Right? The conjugate axis. Conjugate axis, and we'll talk about how to make this box here in a second. We'll talk about how to make this box down here on the graph in a second. Okay, but the conjugate axis is the shorter of the two axes through this box. Okay, so if we want to label them down here. Okay, this is the conjugate axis. Okay, so this is essentially like a minor axis when we talked about an ellipse. Okay, the conjugate axis is the same idea as the minor axis for an ellipse. So for a definition, we can say order of the two axes. Okay, now the other one, okay, the other axis.
I don't have any room.
I'll write smaller. It's called the transverse axis. Okay, the transverse axis is the axis that connects the two vertices. Okay, so from here to here. Okay, the axis that connects the vertices. Alright, so let's take a look at our equations of our hyperbolas here. So, like I already mentioned, our equations are identical to an ellipse with the exception of a subtraction sign instead of an addition sign. Tomorrow's Thanksgiving. School tomorrow.
If we were like every other school in the district, we also wouldn't have school today. But I mean, we're not.
Every school in the district has school today.
No, I guess not. I guess I didn't mean district, but Sandy Valley doesn't, and Perry doesn't.
They don't get a full week off in the spring.
We get a week off.
So
yeah, we get a week off.
For
That's pretty epic, actually. They get like 2 days.
Our two equations, okay, for a hyperbola, we could have the x minus the y, or we could have the y minus the x. If the x is the one that's positive, our hyperbola is going to open left and right. Okay? If our x is the one that's positive, our hyperbola is going to open to the left and to the right. If the y is the one that's positive, our hyperbola is going to open up and down. Okay. If x comes first, it opens in the x direction. If y comes first, it opens in the y direction. Okay? So, if we're looking at our hyperbola, I don't know if I want to explain it in the general form or just do an example. I think maybe just doing an example will make more sense. Okay, so let's say we want to take the equation x squared over 16 minus y squared over 9 equals 1. Right? If I want to graph this equation, I'm going to do a lot of the same things that we did for an ellipse. I'm going to, well, for here, my center would be 0, 0, right? Because I'm not subtracting anything from the x, subtracting anything from the y. Then this tells me how far to go in the x direction, right? The square root of this value. So I'm going to go to the right, 1, 2, 3, 4, and then I'm going to go to the left, 1, 2, 3, 4. This tells me how far to go in the y direction. I'm going to go up, 1, 2, 3, down, 1, 2, 3. Now, these points here allow me to form a box, okay, a rectangle. I'm just going to kind of draw in a dotted rectangle here. Now, I do need to know that since x is first, okay, my hyperbola is going to open which direction? Up and down or left and right? Left and right. So that tells me that these are my vertices. Now what I do, I draw, I guess should make these dotted as well. Okay, I draw dotted lines that go through the corners of these boxes. Little extra. So now, what all of this gets me, okay, is where my hyperbola goes. Okay, my hyperbola is going to be contained in this box and these diagonal lines, okay, on both sides here. And so, if we want to collect all of this information then, okay, EPCA stands for endpoints of the conjugate axis. Okay, so in our example here, the endpoints of the conjugate axis would be right here and right here. Right? Now, we didn't talk about this part yet. Okay, the a squared plus b squared equals c squared. So if you remember for an ellipse, these pieces of information, okay, these were the distances in the x direction, distance in the y direction, and then this was the distance from the center to each focus. Okay, those things are still the same. But for a hyperbola, instead of a squared minus b squared equals c squared, we're going to use a squared plus b squared equals c squared. Right? Now, an important note here, right? Because of that formula, c is always greater than a, or c is always greater than b. Now, what that means is the distance from the center to the foci, okay, is greater than the distance from the center to the vertex. Our foci are going to be inside of each branch of the hyperbola. Okay, so the distance from the center to the focus is greater than the distance from the center to the vertex. Okay, so to find the foci, we would use a squared plus b squared equals c squared. So in our example, okay, we could say 16 plus 9 equals c squared. That would give me 25 equals c squared. So c would be 5, and c is the distance from the center to each focus. C is the distance from the center to the focus. For both an ellipse and a hyperbola. Yes. Right? So yeah, I mean, if you want to make a note of that, again here, C is the distance from the center to each focus. And that is true for both an ellipse and a hyperbola. The only difference for a hyperbola, we're going to say a squared plus b squared equals c squared. For an ellipse, we're doing a squared minus b squared equals c squared. Okay? So our vertices then are, I guess, we already have the answer here. The vertices are the distance of A from the center, right? The endpoints of the conjugate axis are distance of B from the center, and the foci are located at a distance of C from the center. Now, note that these two, A and B, could be flipped if our hyperbola opens up and down. Right? If the hyperbola opens up and down, then the vertices would be up and down. The endpoints of the conjugate axis would be left and right. Questions? Okay, so we already kind of went over the next part, the directions to sketch. Okay, so we said we want to go a distance of A to the left and right of the center, a distance of B up and down to create our little box, and then we sketch the diagonals, which give us asymptotes for our hyperbola. Okay, so let's go through a couple of examples here. So on example 1, okay, we're just asking, does the hyperbola have its transverse axis on the x or the y, and then does it open up and left and right or up and down? So for this first one, x squared over 4 minus y squared over 10 equals 1. So first is the transverse, which is the longer axis on the x-axis or the y-axis. Okay, the transverse axis so I guess it would actually make sense to ask the second part first. Does it open left and right or up and down? Left and right, because x is positive, right? So then the transverse axis is the axis that connects the vertices. So if we're opening left and right, and if we're opening this way, the transverse axis is going to be along the x-axis. Okay, so to answer both parts of the question, x-axis and then left and right. How about the second one? First, does it open left and right or up and down?
Up down.
Up down because y is positive And then the transverse axis would then be
Transverse axis always on like the axis, like the first one, the y-axis.
it always connects the vertices, right? So this one would open up and down. So this axis would be on the y-axis.
Hey.
Questions so far?
Please look at this one.
So, okay, I don't remember the it doesn't matter if they're negative. We just start with one first, the X and Y.
I mean, yeah, it matters. So it matters which one's positive. So I mean, technically, we could write this equation as negative x squared over 5 plus y squared over 8 equals 1.
Okay, so it's not a matter of which one's first, it's which one's positive.
Right. Yeah. Yeah. So in this case, y would still be positive, so it would still open up and down. Right. So I think we have time to get through example 2 here. Okay. So question says find the vertices and the foci for the hyperbola, and then sketch the graph. First thing I need to do is get a 1 on the right side of the equation. So I need to divide everything by 8. So I'll have x squared over 8 minus 4y squared over 8 equals 1. And then I can reduce this to get x squared over 8 minus y squared over 2 equals 1. So I know that my center is at 0, 0. I know I am going to go the square root of 8 in both directions, in both x directions from the center. So the square root of 8 is almost 3. Right? So it would be like here, and here. And then I go the square root of 2 in both y directions. So square root of 2 is like 1.4. And then we make our box. Then I can draw the diagonals of my box. It doesn't really matter if you make them dotted or solid. Now, is this hyperbola going to open up and down or left and right?
Left and right.
Oh, I got X and right.
Left and right, because x is positive. Right? So, to finish sketching this, it'll look something like this. Now, we do still need one more piece of information here. And it still asks me to find the foci as well. So to find the foci, we're using our equation a squared plus b squared equals c squared. So my a squared and b squared are 8 and 2. So I'm going to have 8 plus 2 equals c squared. So that'll be 10 equals c squared, or C10 distance from the center to each foci. So we'll be out here somewhere and out here somewhere for my foci. So I'm going to list this information out as well. Okay, my vertices would be at the point negative square root of 8, 0, and positive square root of 8, 0. And then my foci would be at negative square root of 10, 0, and square root of 10, 0.
Oh, shoot.
Questions?
Here's cheese yellow.
If you could be any animal,